Now, so I am now recording the session. This is going to be probably about sort of 15-20 minutes. I'm going to talk you through the worksheet you've managed to do. First of all, how did you do with the worksheet? Did you manage to sort of come up with some answers?
I did it on the document. I did it on the document itself.
You've done it on the document itself. That's fine. It's just basically a multiple choice quiz, just to really sort of get yourselves warmed up. As I said in my in the task list, you've got a test next week on energy resources. And of course, the week after that, we've got face-to-face lessons again. So what we'll do in the face-to-face lessons is we'll focus a little bit more on practical skills, because I think that's one thing that you've missed out on this term through not being around. We can't really do that many physics practicals very easily, particularly in boarding houses. So we've got here a 15-question quiz. It's pretty simple. I'm going to talk you through quite a lot of it as I go through the answers. Obviously, you can self-assess, and what you can then do is you can assess whether you're red, amber, or green at the end of the live session, and you can let me know. So, first of all, the first questions are fairly simple. Which is a renewable source of energy? So the renewable source of energy, these are ones that won't run out. So we know oil will definitely run out. Okay, that's made from dead biological matter that died millions of years ago. It takes millions of years to form. We've got natural gas is definitely not renewable. So you could either have geothermal or biomass. They're both actually renewable. So either one of these, either A or D, would do nicely. Geothermal will eventually run out, but there's so much of it that it's not going to run out anytime soon. And biomass, remember, is things like wood, biodiesel, and that sort of thing.
So it's one of those options.
Yeah, it can be either one of those. The description that matches wind power. Well, wind power is powered obviously by the wind. We have to ask ourselves what powers the wind. Well, it's actually down to our weather patterns. So wind is powered by our weather patterns, and our weather patterns are powered by the sun. The sun heats up one side of the earth and not the other side, and heats up different parts of the earth by different amounts because of the angle between the rays of light from the sun and the surface of the planet. So you get different areas which have where the air is expanded and heated more than others, and you end up with wind. Yes, Chris?
My Wi-Fi is really bad. So yeah, my Wi-Fi is really bad. So yeah. I might be disconnecting sometimes, but I'll keep on recording.
Well, as I've said before, if you're having really bad Wi-Fi in your boarding house, so I assume you're in the boarding house. If you're having really bad Wi-Fi, you can go and you can ask your house tutor if you can work in the workroom. Okay, I know the Wi-Fi in Brookhouse main building is much stronger. So, which description matches wind power? Well, it's driven by the sun. It's the airflow driven by the sun. So the answer there was A. This next one's quite tricky. We're matching up the information in the table below. So you've got a description of 4 different energy resources, and you've got 4 options underneath of tidal barriers, geothermal, oil, or wave power. So the first one, you've got a description here. The up and down movement due to wind. Well, the wind, what do you mean by up and down movement? Well, it's the up and down movement of water. The wind blows on the surface of the water in the oceans, and it makes waves. So this is actually most likely to be wave power, which was D. Other clues you've got here, we know it's renewable, so it's not, it's nothing like sort of coal, oil, or gas, not fossil fuels, and it's not nuclear power. But it's unreliable due to variable wave height. Well, there's a massive clue there, and it could be damaged by storms. So this is obviously something to do with water and waves. So it must be the wave energy. The next one, number 2, from the remains of buried and decayed plant remains. So it's been deeply buried. So this would be plant or animal. So we're looking for a fossil fuel. So we've got to look for which one of the options is a fossil fuel. Just to double check, what are the clues? Lots of it at the moment, relatively cheap, easy to pipe around. Well, that rules out coal, doesn't it? Because you can't put coal down a pipe. It would be something like oil or gas. And here we have polluting from smog and acid rain, non-renewable fossil fuels, produces carbon dioxide, added global warming. Well, here we've got smog. Now, natural gas, unless it's burnt very badly, doesn't usually produce much in the way of smog, and doesn't produce much in the way of acid rain, but we know that oil does. So the energy resource there is oil. So the answer was C. For information part 3, for number 3, from the mass movement of water due to gravity and the pull of the moon. Well, that's how tides work, isn't it? It's the gravity from the moon pulls on the oceans and cause the sea level to rise when the moon's above the sea. Okay, other clues: renewable, so we know it's not a fossil fuel or anything like that. No fuel costs, so it's not biomass. Very little pollution. Well, that's again quite a few of the renewables, but again it rules out biomass. Less demand on non-renewable resources. Okay, no carbon dioxide. So this is likely to be a renewable resource. And this is costly to build. Well, we know hydroelectric dams are costly to build. Disruption to wildlife habitat. So this is now looking at something like wind or hydroelectricity. Then you've got limited suitable estuary locations. You know that the estuary, which is where a river meets the sea, that's affected by tides and cannot generate power. Here we are when the tides are turning. So again, we've got another massive clue here. So it must be tidal energy. So it's going to be a tidal barrage. A. Then last but not least, from hot rocks underground, due to inactive or recent volcanic regions, active and recently active volcanic regions, we know that's geothermal, because geo means earth and thermal means heat, so it's heat from the earth. That's what this is describing here. So that's going to be B. Right. The next one, you've got to have sharp eyes for this one. If you draw a line where the thread on the thermometer is, you can see it's almost exactly halfway between 101 and 102. So I think the correct answer on that one is 101.5 degrees Celsius. Okay. Number 5, which is a non-renewable energy source of energy. Remember, non-renewable means it will run out. So we know that wood is biomass, that's what's renewable. The solar energy is renewable, as is geothermal. So it must be oil. And a non-renewable source of energy. So we're looking again for one that will run out. So, sorry, another one that will run out. We know geothermal won't run out anytime soon, neither will wood or solar energy. So the answer was C. Okay. Now here's where we think about how we generate electricity. Almost all power stations use an initial energy resource. They process it somehow by heating it, making steam, or maybe passing a fluid through a pipe, running a turbine, and which turns a generator. So we're looking for stage 2. And it's a hydroelectric dam. Okay, there's a picture of it just there. Let's get rid of that. Do bear with me. So we know that that's a turbine. We know that that's a generator. So it's not B and it's not A. While the rainwater in the dam is the initial energy resource, it's the flowing water which goes through the turbine, which generates the electricity. So the answer there was D. Okay. Right. Number 8, which is a fossil fuel. So your fossil fuels are, remember, these are the ones that have died a long time ago, and it's taken millions of years for them to form. So wood is not a fossil fuel because you can just grow a tree and within a few years you can cut it down and burn it. It's not geothermal because that's using the heat under the Earth's crust. It's not sunlight because that's using a nuclear reaction in the sun. So it's C, oil. So number 9, we've got the diagram summarizes 4 stages of producing electricity. This is, again, we've got some clues here in the picture. We're obviously making some smoke, so we're burning something. So this is a heat-based, fuel-based energy resource, but it wants to know what stage 4 is. So which part of that power station actually makes the electricity, and it's the generator. Okay, we're going through this quite quickly. So we're using the words to fill in the blanks. So when we fill in the blanks, we've got here a temperature of 31 degrees Celsius. We may or may not need to use that. It says we measure something using something else. So we've got a picture here of a thermometer. So obviously number 2 is going to be E, the thermometer. So what do we measure with the thermometer? We measure temperature. So that's going to be D. The something of temperature is called the degree C. So that's going to be the unit, isn't it? So that's A. And there's a massive clue here. So what does the C stand for? The C stands for Celsius. So that's B. Okay. The temperature is a measure of how something or cold something is. So temperature is a measure of how, well, what's the opposite to cold? It's going to be hot, isn't it? So that's F. It can change because it's known as, well, in an experiment, the thing that we know that we can change, whether it's a dependent one or an independent one or a controlled one, is a variable, C. Okay. So remember, a variable is something in an experiment that you can change. Sometimes you change it deliberately, which makes it an independent variable. Sometimes it's something that changes as a result of you changing something else, which means it's dependent variable, or it's something you want to try and keep the same to make it a fair test. So I'm just going to try and focus this. It's gone a little out of focus as the room's warmed up. Whoops. There we are, back again. Okay. Right. Number 11, you've got again another power station. This one's for geothermal energy, and it wants to know what stage 3 is. So remember, geothermal energy, we pump water into hot rocks. The water emerges as steam, and then as the water's been heated and emerged as steam, it runs through a turbine, which turns a generator. So it's a turbine, rotating turbine, D. Right, number 12, which of the following fuels would be used for a central heating system? So for a central heating system in your homes, well, you wouldn't really use petrol or diesel. They're used for cars, really. You might use charcoal if you're using a biomass central heating system, but it's not usually used. It's the fuels that are most likely used for a central heating system is actually natural gas. Most boilers run on gas. Number 13, the diagram summarizes 4 stages for a way of producing electricity using wind energy. So which one matches stage 4? Again, what's stage 4 in any power station? The last stage, the bit that makes the electricity, is the generator. Okay, nearly there. Number 14, it's about filling in the blanks, so we have to think a little bit more carefully about fossil fuels. We know that it says fossil something are burned. Well, the clue's up in the first bit here, so that's pretty easy. That's D. They're burned to release something energy. Well, what happens when you burn something? Well, that's going to be thermal.
Heat energy.
Yeah, heat energy, thank you. Now, the heat energy then turns the water into steam. Okay, you boil water, it eventually evaporates and makes steam. And it's the same answer. You've got 3 and 3, so it's the same answer. The steam drives a set of blades. Well, we've got a power station, we're using heat, we're using steam. What's the steam pass through? It passes through a turbine. So that's B, which rotate a something to make something else. Well, that's rotate a generator. We spin a generator around to make electricity. Okay, and so that's C. Now the last one, you have to think a little bit more carefully about. The last one you have to think about says which is a non-fossil fuel, so it's not a fossil fuel. So I'm just trying to find it on my notes here. Hang on, I've lost my pages. Bear with me. Non-fossil fuel and non-renewable. So it will run out, but it's not a fossil fuel. Natural gas, well, natural gas is formed above, is formed underground, usually where there's an oil well, an oil reserve. There's usually natural gas above it. Sunlight is solar energy, that's renewable, that won't ever run out. The battery, well, some batteries are rechargeable, so they could be renewable, but geothermal is also renewable. So it's a battery. And I'll tell you why batteries are non-renewable. The simple reason is we get two types. We've got non-rechargeable. Okay. And non-rechargeable means that when you finish with a battery, you have to throw it away. We also get rechargeable. If you've got a rechargeable battery, then although it seems like it's renewable because you can always charge it back up again using a renewable energy resource, actually they still have a limited life. You may notice with your mobile phones, they contain rechargeable batteries, which is why you have to charge up your mobile phone every night or every couple of days. But you'll probably find that when your mobile phone starts to get a little bit old, whereas before you would charge it up and the battery would seem to last a couple of days, it's suddenly barely lasting a day. And the reason why that is that the components that make up the rechargeable batteries they start to wear out and they decay. And as they decay, the time then obviously the lifespan of the whole battery itself is limited. And with most rechargeable batteries, we usually mine minerals such as lithium out of the ground, of which again there is only a limited supply. So actually batteries are a non-renewable resource, energy resource. Okay, so what I'd like to do now, I'm going to give you a couple of minutes. What I'd like to do, go on the chat box. I will monitor the chat box. And what I'd like you to do is to rate whether you feel that you are green, amber or red on the green, amber or red in terms of being able to do this task. Okay, so I'll give you about 2 minutes to do that. Alexa, set a 2-minute timer, please.
2 minutes, starting now.
Christopher, I know that you and yourself and Christian are both sharing a screen. Could you just let me know which one of you two is Amber, please?
No, so it's Zin and Christian that are sharing, not Chris.
All right, okay. Okay, Zane and Christian, are you able to go on chat on the chat box and rate your understanding? Okay. Just waiting for Zane and Christian to respond. Alexa, stop, please. Okay. From what I've got from your sort of chat responses, most of you feel that you sort of get most of it, but I think you need a little bit of sort of guidance, a little bit of help. So the whole idea about energy resources, just to give you a recap. Excuse my handwriting. The whole idea about energy resources is that they're a place where you get the energy from. And there are two basic types. We know that we have renewable and we have non-renewable. And we get the idea that renewable energy resources will not run out. It's not that they can be renewed. It's the fact they will not run out anytime soon. So things like the sun, as we said before, it's got probably a few billion years left in its life cycle. So as far as we're concerned, it will not run out. But non-renewables will run out. Okay. In geography, just to give you a cross-curricular reference, in geography, they often refer to renewable as infinite resource and non-renewable as a finite resource, because in geography, you don't just look at energy resource, you look at different types of resources, for instance, building materials, that sort of thing. So our non-renewable energy resources, they split into two. Whoops, one and fossil. There are fossil fuels. Fossil fuels are made from dead biological matter, which take millions of years to form. Okay, which is why they run out, because we're using them much faster than we can actually than they're being sort of created. So the ones we remember are coal, which is usually made from dead trees. Okay, and then we've got oil and natural gas. Now, the oil and natural gas, they're formed from they're actually formed from very tiny dead crustaceans that over millions of years have, through the heating and pressure, have changed into a liquid and a gas. And what happens is that where you get an oil well, if that's the surface of the ground, you get like a sort of a pocket underground, and that usually has, where you get an oil well, you have your crude oil, which is black, sort of sticky, very smelly liquid, which can then be separated out into different what we call fractions of oil, such as petrol and diesel. And you also have natural gas. Now, you have to be careful. A lot of people, because they think it's natural gas, thank you, Zane and Christian, for your feedback there. For natural gas, it's a little bit of a misnomer in a way. Although yes, it is produced naturally, a lot of people look at natural gas and think, oh, it's natural, therefore it's renewable. It's not. Okay, there are gases made from renewable energy resources, but not natural gas. Natural gas is the stuff that we drill down for from the surface of the Earth, and we actually sort of extract, and it's usually found in a similar location to oil reserves. Other non-renewable energy resources also include nuclear energy. Well, when we say nuclear, it's actually nuclear fission, which is the nuclear energy that we use to make electricity. Nuclear fission is basically taking very heavy radioactive, very heavy elements, what we call an isotope of uranium, and we subject it to a nuclear reaction. We actually fire neutrons at it, at the atoms, and they split. And when they split, they produce two smaller nuclei and lots of energy. The advantage with the nuclear power is it doesn't produce as much carbon dioxide as coal as the fossil fuels do. The disadvantages of, obviously, first of all, it's non-renewable because you have to get the uranium from somewhere. We dig it up out of the ground. The other problem with nuclear fuels, with nuclear energy, is it's potentially dangerous. If there is a leak from the reactor core, then obviously that spreads radioactive material around in the local environment. If the reactor is not maintained properly or not used properly, then it can undergo what's called a meltdown, which can release radioactive gas for several thousands of miles. For example, in northern Ukraine, just south of Russia, there was the Chernobyl power plant, which, when I was about your age, that suffered a very major meltdown. It's possibly one of the worst nuclear disasters that in recorded history. And when that released radioactive material, that was actually detected over in Britain, which is how we actually came to know about it. Because at the time it was the middle of the Cold War, which meant that the Soviet Union were being quite secretive about a number of things, as well as, of course, the West. So nuclear power is a little bit better than fossil fuels in terms of not releasing carbon dioxide, greenhouse gases, which can lead to climate change. But it does come with problems all of its own, which is why a lot of people don't like the idea of having a nuclear power station anywhere near them, because if something went wrong with it, then it could be life-threatening to them. Disadvantages with the fossil fuels. Well, obviously the disadvantage is, again, as I said, when you burn anything, you release carbon dioxide, which can cause which can contribute to climate change. And the other problems with it is things like coal and oil, particularly, will release other pollutants which are very bad for the environment, including the local environment. For example, in many cities, you're now not allowed to burn coal in a fireplace to heat your house, because when you burn coal, if it's not burned cleanly, it releases carbon monoxide, it releases soot, and it releases sulfur oxides, which can then interact with the clouds and cause acid rain, which then damages plants and buildings. So these all have sort of environmental impacts, and of course non-renewable, which means that they will actually run out one day. Producing electricity by natural gas is one of the most popular ways around the world of producing electricity, for the simple reason that the natural gas turbines that are used to turn the generators can be switched on and off very easily. And because they can be switched on and off easily, we can switch them off when we don't need to produce as much electricity, because we use different amounts of electricity at different times of day. Just to really sort of give you an idea, if we look at the time, say from midnight to say midnight over the course of a day, obviously in the middle of the night, we don't use very much electricity at all. We get to about between 5 and 9 a.m. That's when people are getting up. They're boiling the kettle to make themselves a cup of tea in the morning. So the usage goes up, and it sort of changes throughout the day. What's really interesting is you get to the evening. As you get to the evening, obviously a lot of the industries aren't using quite so much electricity, but people come home and they turn the telly on. So actually, sometimes in the evening, on certain evenings, it can go up a little bit, and then sort of starts to go down as people go to bed at night. But what actually happens is this is very much dependent on what's on television. It sounds very strange. If you take, for example, the announcement made by the Prime Minister on Monday, or you take a key episode of Coronation Street, a soap opera, what actually happens is that either after the announcement and also after key episodes of Coronation Street, a lot of people are watching, and then straight afterwards they go and make themselves a cup of tea. And kettles use a lot of hot water, so what you sometimes get is a big spike in the production, in the use of electricity. So actually, people like the National Grid, who manage the electricity supply around the country, they are often informed before something like a key government announcement or an important episode on a soap opera, so that they know to switch the gas turbines on at a particular time, and so that we can meet that demand. Because if the demand is greater than the supply, then what we get is what's called a brownout, where we're just not producing enough electricity. So these are the reasons why we do still use natural gas a lot to produce the electricity, because you can turn it on and off. You can turn the turbines on and off quite easily. Yeah, certainly more easily than nuclear power, which takes a few days to sort of start up, and coal takes several days. So we go to our renewables, which will not run out, and you've got all sorts. You've got solar energy, both for heating, so to use the heat from the sun to warm up water directly, or using the actual radiation from the sun, i.e. the light and the infrared and the ultraviolet, to actually run solar panels which produce electricity directly. The advantage with solar, obviously, is it's nice and clean. Once you've got your solar panels, and if you maintain them, it's producing electricity for the life of the panels. The disadvantage with solar energy is simply that if you the panels are quite expensive to make, and they do again require some finite materials in order to make the solar panels. And of course, it doesn't work at night, so you have to store the energy somehow. We've got wind energy, like the wind turbines just down the A14, just down the road from us. We've got hydroelectric dams, which are good because, again, it's free energy. It's just catching the rain in the form of water in a river. If it flows down a valley, you can then put a dam across the valley and make a reservoir. That can damage habitats and homes. Obviously, if you need to make a new reservoir, then you've got to flood somewhere. The other downside to hydroelectricity is that you can only put it in certain places. You can't put it where there isn't a valley, for example. We have tidal energy used in the tides, and it's very similar to hydroelectricity. They're both very, very similar. They use the idea of trapping water behind a wall. We can use wave energy. We can use biomass. Now, biomass usually involves energy from biological matter. So these are two types. There are usually sort of biofuels, such as biodiesel, which is started to become a bit more popular, which still involves burning, so it still releases carbon dioxide, but then you absorb carbon dioxide when you're growing the plants you use to make biomass. We've also got, in with that, biogas. Biogas is where we produce methane by decomposing the natural substances, such as your rubbish, for example, and we can use the methane in much the same way as we use natural gas. It's just harder to extract the methane from biogas than it is to just use natural gas. So those are just a few of the energy resources. You need to know which are renewable and which are non-renewable. You need to know what the definitions of them are. You need to have a rough idea as to how we generate electricity. And you need to make sure that you're aware of the advantages and disadvantages of the different energy resources. So to help you with that, your last task for the last 10 minutes of your lesson is to go on Satchel, to go on Satchel, where you'll find a link to a Seneca assignment. It's actually two little assignments, one on renewable resources, one on non-renewable resources. I'd like to go through the assignment as part of your revision and answer the questions, and I look forward to seeing your scores from there. Any questions?
Nope.
Nope.
No? Okay. Right. Well, I'll see you all next week. Next week you've got a test, so make sure you're doing your revision. Do make sure you go through that Seneca task. That will help you with your revision. Make sure that you have the right, make sure that you have a good overview of energy resources, and we'll do a little warm-up exercise next week, and then I'll give you a test to do.
Yeah, okay.
Bye.
Right.
Thank you.
Okay,
See you later.
Thank you. See you later.